So here we are talking about a normal distribution whose mean is 69 inches, because the variable that we are talking about is measured in inches, and standard deviation 2.7 inches. Now we would like to answer the question that what percentage of the values in this population are less than 70 inches. Okay, so what that means is that we would like to obtain this area under the normal curve to the left of the value 70. Okay, we are using again Excel to work on this. So here I opened a file. I'll go to paste functions or insert functions, and I have a statistical selected. If not, I could do that, and then I'll scroll down and I go to normal distribution, and then when I bring the dialog box, I have 70 for my value of x, and then the parameters were given to us. That mean is 69 and standard deviation is 2.7, and for cumulative we are typing true because we want the entire area up to 70 inches. Alright, so when we do that, we have 64.44% of the values below 70 inches. Okay, now say we have to find the area that is on the right of 70 inches, because we want to know the heights of the people or the adult males who are taller than 70 inches. So remember that we just found a short while ago that this area is how much? The area to the left of 70, or the area for less than 70 inches. So this area to the left is, as we determined a few moments ago, 0.644 46726. So if I want this area, the area to the right, then that area will be what? See, 100% of the values should be covered under the density curve. That is, the total area is 1. So if I want the area to the right of this value, all I have to do is just subtract from 1 the area to the left. Okay, and what this value will be, you can use your calculator or just refresh arithmetic and find that. So I'm going to use the calculator. So I'll have equal sign here, then 1 minus, and I'll just ask it to subtract the value on the top. So what do we obtain here then? We obtain that area to the right is, or the percentage of values to the right is about 35.56%, or we can write it here. Okay, let me do that for you. Okay, so that's this value right here. Okay, and what that simply mean is the following, that this area here is 0.3556 approximately, or in other words, about 35.56% of the adults have heights more than 70 inches. Adult males we meant. Now we are taking a different distribution, that say we have a normal distribution in which for which the mean is 59 minutes and standard deviation is 14 minutes, and we have to find the probability that this continuous random variable will take on a value between 40 and 70. In other words, we would like to find the area under this normal density curve that lies between. So in other words, we would like the area from here to here, that lies under the curve, that is we need the value of this area, all right, a proportion of the values under of this normal distribution that are between 40 and 70. Okay, we are using Excel, so what I would do first is that I'll find the area to the left of 40, because that's how the computations were done for us, right? So we go here, and then we will again choose normal distribution. Okay, so I went too far, or here it is. Okay, so I want area to the left of 40, and the mean is how much? 59, and the standard deviation was how much? I forgot. So, oh, it is 14 minutes. So let's go back, and I shall put 14, and we are obtaining the cumulative area. So we are going to say true. So what do we have? That the area to the left of 40 is about 0.874. So we have the area to the left here equal to 0.874 approximately, as I said a moment ago. Now we shall obtain the area on the left of 70 by the same method. That is, we go here and choose normal again, or norm distribution. Okay, here we are. Okay, and we will go to 70, 59, 14, and we are obtaining the cumulative area, so we'll say true. And the area to the left of 70 is how much? About 0.784. All right, that means, what does it mean? It means that this area here, and that is joined with this area here, which is indicated by orange here, entire area, and ignore this, this breaking here. All right. Okay. So this whole area is how much? About 0.784. All right. So this entire area is 0.784 approximately. And what our original question is, what is the area between 40 and 70? So what we have to do here is, so from this whole thing, if I just took this area away, that is, if I subtracted this value from this one, then what will happen? I'm going to get the area in between these two. So let me first undo my cutting here. Okay, so we are going to take the difference of this value and this value to get value between, and we shall use our calculator. Okay, here we go. We'll say, well, subtract the top cell from the bottom cell, and what does it tell us? That about 70% of the values are between 40 and 70, or in other words, the probability that it will take between 40 minutes and 70 minutes is how much? It is 0.6966, and you just round it to the up to the places it's asking you to. All right. Now we are going to do a slightly different kind of calculation. That is, say we are looking at this question, that we have a normal distribution with mean of 1000 and a standard deviation of 200. And instead of finding that what is the area on the right or left of a particular point, we have to find this here, that how much should I have, or what value should I have, so that the 10% of the values are over that particular number. Okay, so what we have is here that we would like this, that as I said, what is this value for this given normal distribution, so that the area to the right of this value is 10%, all right, or in terms of proportions it's 0.10. Now we are going to use Excel for this particular question. And for Excel, remember, we can talk in terms of the cumulative area up to that point, which means area to the left. So if we are giving this question to Excel, it will do the reverse calculation for that for us. And so, but in order to communicate with that dialog box, what we will need is that we will need to give the area to the left, that is the cumulative area, in order to get this number. Okay, so if the area to the right is 0.10, then the area to the left is how much? 0.90, or in other words, we are computing the 90th percentile of this distribution. So let's go back to Excel and erase these calculations that we had before. Okay, and again go to statistical, go for normal distribution. No, this time what we are going to do is we are doing the reverse calculation. So we'll say norm inverse. Okay, all right. So now when it says probability, we are going to put the percentile that we have there, that is probability that the uh, variable will take a value below the number that we are wanting, is 0.90 in this case. So mean is 1000 and standard deviation is 200. So what do we get here? That this is 1256.31, and it depends on the way the test is scored, how they want to round it, or that's not a decision that we are making. Okay, so what we have determined is this, that the 90th percentile, okay, of this distribution is how much? It's 1256. I don't know whether it's fitting in the screen or not. Let me just put that at a different place here. That is the value that we found for this question mark here is 1256.31 approximately. Okay, so if they are looking for the cutoff to be, for the top 10%, it will be 1256.31. Now let's take the last example in this discussion, that we are looking at, say, this question, in which we are given that the weights of people in a certain region show a mean of 180 pounds and a standard deviation of 35 pounds. And what we have to do is that we have to use the central limit theorem to calculate the probability that the total weight of 100 people, which we are going to consider as a simple random sample from this population, will exceed 20,000 pounds, that is, will be more than 20,000 pounds. So what does central limit theorem tell us? That for large sample sizes, means of simple random samples will show approximately a normal distribution. And the mean of that distribution will still be the same as the mean of the population, that is 180 pounds in this case, and standard deviation will be lower because the means are distributed more consistently. So we have the population standard deviation divided by the square root of the sample size. So square root of 100 is a 10. So 35 over 10 is how much? 3.5 pounds. and we have to compute the probability that the total is more than 20,000 pounds. Now, since we are talking in terms of the sample means, we will change it in terms of the mean of the sample. Okay, so we are looking at sample mean being higher than how much? 200, sorry, 20,000 divided by 100, which will be what? 2,000 pounds. Okay, so what we get is this, that we simply have to compute the probability. Oh, here I made a mistake, I'm sorry. Okay, this is 200 pounds, all right. That a random variable with mean 180 and standard deviation 3.5 with normal distribution will have a value of more than 200. Now, if we use Excel as we have been using for this calculation, then again we have to, Excel will give us the area to the left, right? So we go to insert function. Okay, and now we are going to use normal distribution this time because we want the area. So how much is our x? It's 200 pounds. In fact, literally it's x bar, or the sample mean, and the mean of the distribution is 180. Standard deviation is 3.5, and of course we are talking about the cumulative, right? Okay, says so the so we get 0.999, 9 and a bunch of nines, then 4. And what this means is that the probability that the total weight will be less than 20,000 pounds is how much? This much. Now, the question is asking us to compute it, that what the probability will be for more than, right? Okay, so let me increase the font size. So how do we compute the probability of more than? We will just take 1 minus this number that we have here. So that probability is, well, we have 10 to the negative 9 here. So we will have 0.00. How many zeros? 8 zeros, then 5, 5. Okay. Or in other words, let me just write it in our document. Okay. So we come back here, and so our answer will be what? 1 minus what we had there, and that will be, well, here we are taking this 4 here, so we will have 0.0000. How many we needed? 8 of them, right? So here, so it's like it's a very low probability. Okay,